what is your definition of SEM? Have you ever used structural equation modeling in any of your research work, or have studied something about it? Have any idea what SEM is?
In SCM, like what basic idea I have is like diagrammatically we try to show the relationship between the independent and dependent variables.
Mm-hmm.
That's some idea what I have.
Okay, that's good. Anybody else?
Can I answer, ma'am?
Yes, sure.
Yesterday, our second presenter, Dr. Shashikumar, was telling that when you are going with research, always try to go for new research. That is, try your own models, add to the research literature. And somewhere, I feel that SEM fits into that, that space where definitely it can be used to go about with finding new models rather than only depending on the data analysis for the old models. So that is what, because you will be understanding the relationship between the independent and dependent variables. So this is an idea. Please correct me if I'm wrong.
Okay. So that's
Monica ma'am, if you open the chat box, there is an answer, like one or two answers are there. Yeah.
Let me try to.
I'll read out, ma'am.
Yeah, I cannot access the chat somehow when I'm in this video.
Yes, ma'am. I will read out, ma'am. Dr. Vasudha. So, ma'am has told, yes, SEM is used to measure the robustness of the entire research model hypothesized.
Mm-hmm.
And another madam, that is Professor Surubi, a model is created including various variables of the study so as to propose new relationships.
Mm-hmm.
So these are the two answers we got, ma'am.
Okay, this is a similar response to what you said as well. So combining all of those, I am going to explain how, yes, SEM is defined, and I'm going to combine all those responses of yours in when I'm going to explain what SEM is according to how I put it in this PowerPoint. So this is a simple model where the IV, independent variable, leads to DV, the dependent variable. And just to simplify, and I've just made this up, this is nowhere a model, I've just made this up, that if hard work is the independent variable, the dependent variable can be academic performance. So if your hard work is, if students, level of hard work is more, their academic performance is also going to increase. So hard work and academic performance have a positive relationship with each other. So this is a kind of a normal model, if we can call it, just having an IV and DV. This is a normal model that can be tested, and let's forget about SEM right now, but it can be tested using what analysis? What do you think we can test this model with? What analysis can be used?
Regression.
Okay, regression. What we have linear regression, we have multiple regression. What type of regression would you use?
Simple linear regression.
Simple linear regression, that's right. So when we have one IV and one DV, we use simple linear regression or linear regression. Now let's make it a little bit complicated and add another IV to it. So our IV number 2, let's say, is intelligence. So hard work and intelligence both lead to academic performance. How would you test this model?
Can use multiple regression?
That's right. So we'll use multiple regression here. So multiple regression is used when we have two IVs or multiple IVs, more than one IV and one DV. Now let's make it a little bit more complicated, and let's add a second DV to it, and let's call it wisdom. And as I said before, I've just made this model up. It does not exist. So just for the sake of this session, I just made this model up. So now I wanted to bring in something that makes sense to everybody of finance, of economics, or whatever your background is. So let's say hard work and intelligence both lead to academic performance, and both also lead to wisdom. How would you test this now?
Multivariate analysis.
Multivariate analysis, which is again, what is multivariate analysis? You have to have one of those. You have to have regression, ANOVA, all of these are part, or ANCOVA is a part of multiple regression, multivariate analysis. So you can use any of those. But you keep in mind that when you are using, let's say if you want to use multiple regression, what you will have to do is you'll have to divide this model into two parts. That is, you'll have to go back to this and then analyze it. And then you can get rid of DV1 and just analyze IV1 and IV2 leading to wisdom, DV2. So the multivariate analysis that we have, apart from SEM, all of those can test this model, but you will have to divide the model into different parts in order to test it. However, SEM can test the model together without you having to divide it, because SEM does that work for us. SEM basically combines different statistical tools and tests the model for us as a whole. Now we can also make it a little more complicated and add another DV, let's say job, that is the job that the students will get, job quality to it. So your hard work and intelligence lead to academic performance and wisdom, and your academic performance and wisdom will lead to the job quality that you will get, the quality of the job that you will get after you graduate from your school, let's say. So this complicated model can be tested using structural equation modeling in one go, at once. You don't have to divide this model into different parts, but you can just test it in one go using SEM. So coming to the definition of SEM, it's a collection of statistical techniques that allow a set of relationships between one or more independent variables and one or more dependent variables to be examined. So we can examine all of these IVs and all of these DVs together, put them all together, and SEM is just going to do the job for us. It's going to analyze the whole model together for us by using a collection of statistical techniques. Now, there's also one more point to this, that when we analyze our models, that is, when we analyze our models with regression, with multiple regression or linear regression or any other kind of analysis that you want to use, when we analyze using those analyses, it divides the model. It breaks down the model into different pieces, which sometimes does not make sense. For example, we want to say that hard work and intelligence both together do lead to academic performance and wisdom, both, and these both together lead to the job quality. So we basically want to say that all of this together makes sense, but we don't want to study it separately. We don't want to break it down into different pieces. So you have to think about when to use SEM, the question when to use SEM. You have to think about, do you want to measure the whole model together, or do you want to break it down into different pieces and then study it? So if you want to put it all together and then analyze it, then you have to go for SEM. Now there's some other names for SEM. It's also called causal modeling, causal analysis, simultaneous equation modeling, analysis of covariance structures, path analysis, or confirmatory factor analysis. Even though path analysis and
Dr. Monica,
yes,
I'm sorry to disturb. There is one question, ma'am, that is Kitty Sandeep Rana has asked this question, ma'am. Is there any limit to the number of DVs, that is dependent variables and independent variables?
No, the simple answer is no. There is no limit to IVs and DVs. You can have as many as you want. The question is that do you want to have how many DVs or IVs do you want to have in your model? Because you don't want to, sometimes we just think the more complicated the model is, the better it is. But in my experience, in my reviewing papers for journals, the simpler the model, the better it is. Just an added information there. But the answer to your question is no, there is no limit. You can have as many IVs and as many DVs as you want, as long as the model fits. And we'll talk about the model fit later on in the presentation. Any other questions?
Ma'am, no, ma'am. That was the question. So, is it fine if I keep asking the questions whenever the participants will ask, or should I put it at the end? What is your?
Sure. Go ahead, ask them while they come in, because then
okay,
we'll be in that. At that point, it'll make more sense.
Thank you, ma'am.
Okay, so path analysis and confirmatory factor analysis are a little bit different than the actual SEM, and we're going to talk about these later on in the presentation. Now, you can also test, at this point, I want to say this, that you can also test mediation models and moderation models using SEM. And I want to ask if you know what mediation and moderation models are.
Please type in the chat box. The question was, do the participants... Yeah, please repeat, ma'am.
What is a mediation model or a moderation model? Are you aware of what these models are?
Ma'am, one suggestion is, would appreciate some explanation. So it indicates that explanation is required.
Okay, so I'm just going to click here because we are going to go a little off topic here. So I have put some slides at the end of the presentation. So I'm going to go there directly, and we're going to cover this in brief.
I'm sorry, there is one answer from Dr. Vasudha. Mediation is about the relationship between the variables.
Okay. Okay, so yes, it is about the relationship between variables, but there is a specific type of relationship that these variables have in mediation model. For example, the one that you see in here. So you have this mediation model kind of makes like a triangle, the way you see it here on the screen. So the independent variable leads to dependent variable through a mediator variable. So basically, we have the same path, that is IV leading to DV, but the mediator variable kind of provides an explanation of why IV leads to DV. And we'll just go directly to an example. For example, grades, high grades, if there are high grades, higher the grades, higher will be happiness. So as grades go up, the level of happiness will also go up. Now this is not the mediation model. This is just the main effect, as we call it. This is just the plain IV leading to DV. The mediation model is that which gives us an answer to why do grades make people happy? Why does high grades lead to higher level of happiness? And the answer lies in self-esteem. So grades lead to happiness because of high self-esteem. So to put it in plain English, it just answers the question why. So a mediation model is where you have a mediation. It generally is a psychological factor, and the mediation basically explains the relationship between the IV and the DV. So grades lead to happiness, yes, but why do they lead to happiness? Because grades actually lead to high self-esteem, high grades lead to high self-esteem, and high self-esteem then leads to higher level of happiness. So that's how a mediation model works. Any questions?
I would like to excuse, ma'am, because about moderation, we got at least two answers. So
Okay.
moderation, Dr. Vasudha again has given this. Moderation is about the strength of the relationship between IV and DV through the MV. And there's another participant, Reena, Professor Reena, and Madam has told when the impact of independent variables on dependent variables get increased, that is either increased or decreased, it is moderation. So these are the answers we got for moderation. Of course, another answer, moderation is about the strength of the relationship. So these are the answers we got, ma'am.
Okay. Okay. So yes, moderation, and we'll talk about moderation after this. Does anybody have a question regarding mediation at this point? Or did you understand what a mediation model is?
Yes, ma'am. At least they have understood. That's what I
Okay.
got. Yeah.
Okay. All right. So yes, somebody correctly said a moderation model is when the IV leads to DV, but the moderating variable makes some change in that relationship. It can be an increase or a decrease, or it can just completely make the direction opposite. That is, when the IV increases, the DV increases. If the main effect is that IV increases, the DV increases, the moderator can make such an impact that when the IV increases, DV can actually go down, it can reduce. And we'll try to understand this as well with an example. Now here on this slide, you see that there are two moderators. So there can be more than one moderator. Same goes with mediation. There can be multiple mediation models, and that's also a possibility. The same way, there can be more than one moderator in a relationship. And to try to understand this with an example, if we look at this model, the simple model, stress leads to depression. So as stress goes up, the level of depression also goes up. That's the main effect. But the moderating variable here is social support, and that's how it's drawn on this model. That is, if your social support is high, your the level of depression will go down. The level of depression will be low. So as somebody said before, it can go up, it can go down, or it can take the opposite direction. So if your stress is high, your depression is actually high. That's the main effect. But with social support, if you have a high social support, if you have a lot of friends, or just one friend who is enough for you to give you the social support, your high level of social support can reduce your level of depression. Low level of social support will still have the same relationship, that is, stress increases depression, but high level of social support can reduce your level of depression. So that's what a moderation model looks like. A moderator is supposed to change the relationship between the IV and the DV, somehow change that relationship. Any questions at this point?
Yes, ma'am. Actually, Professor Gurvind Kaur, ma'am, asked about mediation. Is mediation model somewhat related to partial regression?
Okay, so there is in mediation model, and I'm trying to go back here. Yeah. So in mediation model, and I actually removed the slide at the last moment. But yes, in this model, what happens is that the IV, that is, for example, here grades lead to happiness. Okay, that's a direct relationship. So you can test it, yes, using partial regression. How your grades will lead to happiness, right? And the mediation model that we are trying to test is that grades will lead to happiness through self-esteem. So what this model, if you want to test this mediation model, what you have to test is that do grades lead to happiness directly, or do they lead to happiness always through self-esteem? So you can have complete mediation, which means when you are testing all these three constructs together, and we call them constructs, when you're testing all these variables together, then your grades should not lead to happiness. It should always lead to happiness through self-esteem. That's called complete mediation. If your grades lead to self-esteem and then they lead to happiness, but also grades lead to happiness directly in the presence of self-esteem, that's called partial mediation, which means that grades can directly lead to happiness as well as they can lead to happiness through self-esteem. So that's called partial mediation. So yes, the answer to your question is we can test it using partial regression, because depending on if you have a partial mediation or a complete mediation, you can check, depending on your model, you can check that. And both are considered to be mediation models. So yeah. Okay. Any questions about the moderation model?
But there's one more. I don't know whether this is a question. So Professor Indranil, mediation explores the joint significance of the two paths involving the mediating factor. I think that's an answer to the question.
Yeah, that's right. It does analyze the combining them together. It does analyze the mediation model. All right, let's move ahead.
Yes, ma'am. No questions.
Okay. So now we can also have a model like this, a mediator and when we have a mediator as well as a moderator variable in the model. That is, you have the IV leading to DV, and then you have a mediator variable in there, and then there's also a moderator variable. And these three that I've shown you are the simplest forms of mediation and moderation models. You can make them as complicated as you want. You can put this mediator over here, you can put it over here. If you put it here, it becomes a moderating mediation model. If you put it here, it becomes a mediating moderation model, and so on. So you can also have multiple mediators, as I said, you can have multiple moderators, and you can test them all using SEM. So going back to our original slide, which is what is SEM. So SEM basically can test all these complicated models in one go, in just putting them all together as a whole. They can test this model. So what are the advantages of SEM model? Why should we use SEM model? And we already talked about this. These test models, SEM tests models with multiple dependent variables. That's an advantage of SEM. It can just put them all together and test it as a whole, the model as a whole. Ability to model mediating variables, and we talked about that just now. And ability to handle difficult data. That is all of these complicated models that we have. It has the ability to handle that. It has the ability to handle a lot of data, and we're going to talk about that as well. Now, limitations.
I'm sorry to interrupt, ma'am. Madam Vasudha ma'am has asked, can you give a simple definition of mediation?
Mediation explains, if I have to define it, I haven't defined it ever on my own, but okay, if I have to define it, mediation explains the relationship between independent variable and dependent variable. That would be my simple definition. It explains the relationship between IV and DV.
Good morning.
Thank you, ma'am.
Can I, with your permission, can I add something to it?
Sure.
Suchitra madam can, for example, let's take an example for exercise and weight loss. Exercise is an independent variable and weight loss is a dependent variable. So the calorie, suppose there are other variables, caloric intake, gender and age. Caloric intake, I think so, will be a mediating variable because it must have a causal result of an independent variable, and it should be a causal antecedent of a dependent variable. Whereas gender and age, it is not a causal result of a dependent variable. So gender and age, I think so, are moderator variables. Ma'am, am I right?
That's right. Gender and age are moderating variables, always.
Because yes, because they are not a causal result of independent variables. Whereas caloric intake, that can affect the dependent variable. If it increases, it depends, it affects the weight loss, or it decreases. So it has an effect, and it is having a causal result of the independent variable. And it is a causal antecedent of a dependent variable. So that is, I think so, mediators and moderators. If with one example, it can be set.
That's absolutely correct. So that's how the moderators are generally gender and age are generally used as moderators in research. They can also be IVs depending on what you're studying. And another, if you want to understand this mediation in simple terms, let's say, for example, I'm just going to talk about something that we all do on our day-to-day basis. For example, if you want to go to you want to leave your house and go to college. So you are going to leave your house, and so your IV is your house, because that leads to going to your college. So your DV will be your college. So yes, you leave from house and reach the final destination, which is college. But in between, the mediating variable can be your bus stop, for example. So you have to go to bus stop in order to go to college. So when I talked about the complete mediation and partial mediation, complete mediation will be that you leave from your house, have to go to the bus stop in order to reach your house. So if somebody brings in bus stop in your conversation, you're not going to ignore bus stop. You're going to say, yes, I go from my house to the bus stop, and from bus stop to the college. But if nobody brings in bus stop in your conversation, you're going to say, yes, I leave from my college in the morning at 8 and reach my home in the morning at 8 and reach my college at 9 a.m. for example. So you have a starting point, which is an IV, and a destination point, which is DV. But there is something in between the IV and DV, which you sometimes study and sometimes you do not study. In the mediation model, you study that in between path as well. Now, if you have a partial mediation, it means that sometimes you do not go to the bus stop, you just directly go to your college. So that's a partial mediation, whereas where you say that I do not go to bus stop always, I just take my car, for example, from my house and go to the college directly. So you have that covered, that main effect covered, as well as the bus stop covered, because sometimes you do take the bus. So the mediation variable actually explains or provides you the mediating path that you take before you reach the DV. Does that make sense?
Yes, ma'am. There's one more question, ma'am. How many levels of moderators and mediators can be incorporated in SEM? Is there any limit? And this has been asked by Professor Ramanjanelu.
Okay, so the mediation has no limit, but the moderation is a difficult task in SEM. In fact, some people believe that moderation cannot be checked. It cannot be tested in SEM, which is not true. It can be tested, but it's a very complicated process to test multiple moderators. So you can test the more than one moderator in SEM, but for that you'll have to make some calculations. So you'll have to create the an interaction variable and then go from there. Are you aware of that, the interaction variables? So if we go, let me go back here quickly. If this is our, when we are conducting analysis, what analysis does is it checks the impact of stress on depression. That is, how much impact does stress have on depression? Mathematically, what these analytical tools do, they actually take the moderator, so and treat it as, multiply it with the IV and treat that as an IV. So mathematically what happens is that these tools, what they do is they multiply stress with social support and make that as an IV, and then they check its impact on depression. That's how moderation is calculated. So this can be done. You can manually do that. If you have multiple moderators, you can just multiply these and then create another variable and test the impact of that IV on the DV. So yes, you can have as many moderators as you want if you want to do it like that. But automatically, the Amos software does not do that. It only does it. It has a limit of the moderators you can have. I have only conducted analysis with one moderator. I've never had more than one moderator in a model while using SEM, because I think it just dissolves the purpose of using SEM if I have to do the manual calculation. So yeah, so you can have as many mediators as you want, but I think it does have a limitation on the moderators that you can have in a model.
Ma'am, there's another question. How do we decide that which variable is a mediator or which is a moderator? If you can explain again, ma'am, to make it more clear.
Okay, so how do we decide? So we do not decide that, first of all. Whenever we create a model, we create it on the basis of some theoretical background. So you have to see, and let me go back here. Yes, if you look at that model here that I have created, of course, as I said, that I've just made this up. It has no theoretical background, but I wanted to make some logical sense to it at least. So if you look at it, you see that hard work leads to academic performance, will lead to the job that students are going to get. The quality of that job has at least a logical sense here. As I said, there's no theoretical background behind this, but it has a logical sense. Similarly, if you do not want to start from theory, if you don't want to start from literature review, and you want to start from making a logical sense, which is also okay. A lot of researchers do that. They try to create a model based on logical sense. If you want to do that, then if you see hard work will lead to academic performance, will lead to job quality, makes a logical sense. So how do you decide? You just look at it and you see that, oh, this is what's logical. Now, it has a logical sense, but you still need to go back into literature and see if any theory or any paper supports your logically made model. So if it does not support, and this is actually the way a lot of researchers conduct their research or come up with different models, that they try to make a logical model, and then they go back into the literature and see if that has support in the literature. If it does have support in literature, go ahead with that model. You're doing what you're supposed to do. If it does not have support in the literature is then going to take the front seat, and it's going to tell you where you're going wrong. So you don't really decide. It's the literature that decides. It's the theory that decides what variable is a moderating variable and which is the mediating variable. Does that answer your question?
Ma'am?
Yeah.
I have a request that we'll move forward, because I think you are supposed to even take the software, teach us the software. So shall we take the questions at the end, ma'am? If that is okay with you.
However you want to do it. That's okay.
Yeah. Thank you so much, ma'am.
Okay. All right. So now we have these advantages of SEM. We talked about them. Let's talk about a few limitations of SEM model. Now, SEM does have more than these three that I have listed here, but I have listed the main limitations here. The first one is high sample size requirement. You cannot go for structural equation modeling if you have less than 200 sample size. That's the minimum that you need to have, and 200 is considered to be a big sample size, and you have to see how many variables you have in your model. Based on that, you calculate sample size, and there are many papers that they're going to tell you how many you need. Generally, it's 10 people, 10 respondents per indicator, and we're going to talk about that later. But yes, put it simply, you need a very high sample size in order to go for this analysis. SEM does not it does not conduct analysis on missing data. It's very bad at it. It does not like missing data at all. Do you know what missing data is?
When the respondents do not fill the data in the questionnaire.
That's right. So when the respondents do not fill the data in questionnaire, you can still conduct regression analysis. You can still conduct ANOVA. But for SEM, you cannot do that. You cannot conduct SEM with missing data. You have to estimate some responses for missing data, which you have an option to do that in Amos. If you have missing data, it's okay. You can still, you have to check on that option over there, but it's not going to perform the analysis on your data if there's something missing in there. And the third one is correct model specification. That is, we're going to talk about model fit that I had talked about previously. I just touched on it previously. It does need correct model specification. And we'll talk about this a little more when we talk about confirmatory factor analysis. That is, it needs the model to fit together. Okay, we'll talk about that later on. But let's talk about a few symbols and vocabulary. Observed variables, as you all might know, that these are the variables that are just observed. You just look at that, for example, gender or age. You just put them in. You know the gender. You ask people their gender, and they tell you male, female, or others, and you put that in. You ask people their age. You say, what is your age? And they just give you their age, and you put that in. So those are observed variables, which is opposite of latent variables, which are the ones that you cannot observe. And we're going to talk about that a little more again in a minute. But the symbols that we use in SEM or in Amos, and even otherwise when we draw models, are what we're going to talk about here. So for observed variables, you make this box or a rectangle. For latent variables, you make these ovals. So whenever you see a construct in an oval, you know that it's a latent variable. Whenever you see a construct or in a rectangle in a box, you know that it's an observed variable. Direct effects are represented by this arrow. And then we have reciprocal effects, which is that the A leads to B and B again leads back to A. That's represented by these arrows. And correlation or covariance, which I think you've covered yesterday, is represented by these double-sided arrows. Now, if you look at this model of ours, you can see that all these are latent variables because these are in the ovals. And you also see direct effects because you see those arrows going from IV to DV and then DV1 and DV2 to the final DV. And we do not have any reciprocal effects there. So you just look at that model and you know that what kind of variables there are, what is the impact, which variable has an impact on which other variable. Exogenous variables are the ones that are not affected by other variables in the system. These are also, you can think about IVs here. The independent variables are not affected by other variables. So these are exogenous variables. Endogenous variables are changed or determined by its relationship with other variables within the model. And these are generally the DVs, the mediators, all of the variables that come inside the model. Those are endogenous. Structural model is the set of exogenous and endogenous variables in the model with arrows and disturbance terms. So you have this model that we were looking at. This is a structural model because it has the IVs, the exogenous variables, and DV1 and DV2 and DV as the endogenous variables. So this is a set of exogenous and endogenous variables in the model with arrows. We have those arrows and disturbance terms. Do you know what disturbance terms are? We may sometimes call them confounding variables as well.
No,
Ma'am, they don't know, ma'am.
Okay, so the disturbance terms or confounding variables, as we call them, are the ones that we do not study, that we do not want to study. So we are studying the impact of intelligence and hard work on academic performance, right? But there are some, we cannot say that academic performance is solely based on intelligence and hard work. There are some other disturbance terms that impact our academic performance. For example, your situation in the family, right? Or having a girlfriend or a boyfriend, having a relationship while you're in college. That can impact your academic performance as well. So all of these other variables that you are not interested in studying, but they are still there, they still exist. Those are called confounding variables, or we can call them disturbance terms here. So we need to be aware of, even though we're not studying them, we need to be aware of those disturbance variables or those confounding variables. And if the need be, we may need to also control for them. We may also need to check whether their impact on our respondents, the sample that we have selected, is too much to impact our model that we are testing. So those are, just an added information that these are the confounding variables that kind of are a part of structural model because they are impacting it, but they are not a part of the model that we want to study because we are not interested in them. These are just disturbing our model, and that's why we want to keep them in our structural model. And the last one is measurement model. It's that part of SEM model dealing with latent variables and indicators. And as I said before, we're going to talk about latent variables and indicators again, and we will talk about this in a minute. We'll come back to that. But first, I wanted to just touch on this path model, which is a special case of SEM. where all these constructs that you see are observed variables. How do we know that these are observed variables?
The shape of
All
it.
squares are there. Yeah.
Exactly, because these are all boxes, so we know that these are observed variables. So a path model is the one in which we have all observed variables. Now here we see 4 regression path coefficients, A leading to D, B leading to D, C leading to D, and D leading to E. So if you want to see individual regression, the linear regression paths, you see them here. There are 4 in here. And there are also 3 pairs of covariance among the variables, A and B, B and C, and A and C. All those variables, the exogenous variables that are there, they have a covariance among them. So this is a simple path model. Path model, which is a specific type or special type of SEM model, is the one which has all observed variables. Just wanted to touch on that, and then we'll go to our measurement model. That's where we had left. That part of SEM model dealing with latent variables and indicators. Now, do you know what latent variables are? Or you have an example of latent variable?
Variables which are not observed in the study.
For example?
Job satisfaction.
Job satisfaction. Okay, that's correct. So you will not ask your respondents, are you satisfied with your job or not? I mean, they may give you an answer to that, but that may also not give you an answer to that, because a lot of times people don't know if they are satisfied. Even they don't know if they're satisfied or not. Or for example, if you want to ask, what is your attitude towards your job? That doesn't even make sense, that question. So attitude is also a latent variable because you cannot directly observe, but rather you're supposed to ask different questions. You're supposed to ask other questions in order to get an answer to job satisfaction. So that's a latent variable where you do not directly observe, but you have to ask infer your answer from other variables that you use. And these other variables are the indicators. These are observed variables. These indicators give you an answer to the question that's asked in the latent variable. And that usually has a measurement error associated with it. So these indicators that give you an answer to the latent variable, these have a measurement associated with them. That's something you just need to know, that there's always a measurement error associated with indicators. Now the model that we see here, and this is the model that we are going to test if you have received the file, the data set that I have shared, or maybe now you're going to see it in some time when we're going to test it.
Shall we share it?
Not yet, but I just want to talk about that. So there's a data set that I would like to share with you guys so that we can work on it hands-on. But this is what we are going to test using that data set. So this is a tiny part of my study that it's already published, so I don't have any problem in sharing the data or anything with you guys. But this is just a part that I've taken from that study and not testing the whole model, because I just wanted to do some hands-on exercise here. So the model is that the first hypothesis is that empathy, and this is talking about advertising. So we are talking about empathy in advertisement. If there is empathy in advertisement, it leads to high attitude towards the ad. It improves consumers' attitude towards the ad. And then hypothesis number 2 is that when attitude towards the ad is high, the response to the ad is also high. Now, what is response to ad? Here, the study was about advertising on social networking sites like Facebook, Instagram, etc. So the response to the ad is like, share, and comment. And this is an old study, so we didn't even have all those reactions at that time. We only had like, share, and comment. So that's the response. That's how we are measuring the response here. So this study says that empathy in advertising increases the attitude towards the ad, and that in turn increases the response to the ad. So these are the two hypotheses that we're going to test in this model. Now because all of these are latent variables, we had to use, we could not ask people, we could not ask respondents, do you feel empathy towards this ad? That did not make any sense. So what we did is, instead we asked these 5 different questions in order to get an answer to the latent variable, that is empathy. So these are the 5 questions we asked. While watching the ad, I experienced feeling as if the events were really happening to me, and so on. So basically we asked 5 different questions in order to get a response for empathy. Similarly, for attitude towards ad, we asked these 4 different questions. That is, did you find the advertisement unfavorable or favorable, negative or positive, bad or good, no liking or liked a lot? And then, so we asked 4 questions here. And then for response to ad, we asked, are you, how likely are you to like, share, and comment on the advertisement on Facebook? Unlikely, likely, definitely not, definitely, and probably not, probably. So these are the 3 items we used, or 3 indicators we used to capture response to ads. So once again, we used 5 indicators for empathy, 4 for attitude, and 3 for response. Okay, just want to say that here because we're going to go back here, the measurement model, to our measurement model. That part of SEM model dealing with latent variables and indicators. So the one that we saw before was our structural model, where we saw a relationship between empathy and attitude and response. The measurement model does not have those arrows in between. We have deleted those for measurement model, but we are interested in the latent variables and their indicators, that is empathy and its 5 indicators. The indicators are observed variables, and that's why they are put in those boxes. So E1, E2, E3, the capital E1, E2, E3, E4, E5, these are empathy 1, empathy 2, empathy 3, empathy 4, empathy 5. All of these are indicators of empathy, and that's how you're supposed to write them. And you, in the beginning, you said that you covered factor analysis yesterday, so probably you're aware that that's how they are written, or that's how they're drawn. And as said before, indicators usually have measurement errors associated with them, and that's why we have those small E1, E2, E3, E4, E5. Those basically represent the errors associated with indicators. Our attitude towards ad had 4 indicators, or 4 questions that we asked there. So we have A1, A2, A3, A4, and again, errors associated with them. Response had 3 questions, so we have R1, R2, and R3, and then we have errors associated with them. So these show the measurement model. Now, confirmatory factor analysis, what it does is, and do you know what confirmatory factor analysis is?
We confirm the factors.
That's right. So we confirm that the factors that we have, the indicators that we are thinking, give an answer to the latent variable, that we confirm that these really are the indicators. We confirm that these really are the factors associated with the latent variable. So confirmatory factors, we have EFA, which is exploratory factor analysis, where we just explore. We don't confirm, we don't know, we don't have no idea. We just put some questions in there and we say this should measure empathy. And then we just explore. We put it in the system and ask the system to explore and tell us that these are the factors of that latent variable. However, confirmatory factor analysis comes after EFA, after exploratory factor analysis, which confirms that yes, these are the factors that are associated with the variable. So our confirmatory factor analysis is the first step in SEM. So when you're going to conduct structural equation modeling, when you're going to conduct that analysis, the first step is to confirm that your factors fit in the model and your constructs, your variables, empathy, attitude, and response, all of them have a model fit. They all fit together. Remember, this was one of the limitations or one of the challenges of SEM, that this has to fit together. The model has to fit together. Because you are testing the whole model together, you're not breaking it down into different pieces. You have to make sure that the model fits together. And going back to somebody's question who asked, can we put as many IVs and as many DVs in there? Yes, you can put as many IVs and as many DVs in there as long as the model fits together. And how do you know the model fits together? Is by conducting confirmatory factor analysis. So we conduct this analysis by drawing this in Amos. And at this point, I would like you to share the data set that I had provided you.
Okay, ma'am. We will share it.
And just so that I know, are you are you going to work on Amos side by side, or do I just go through it? Does anybody have Amos? Are you going to work on it?
Ma'am, we have.
Okay, okay.
I have mailed the data set and also posted the data set in the WhatsApp group. Okay, I'll also put it, can I attach it here? Can anyone confirm me whether you have received the mail?
Yes, ma'am, received.
Okay, okay.
Ma'am, we have received but not able to open that file, SAV file.
You should have SPSS in your laptop, then only it is .sav file, ma'am. If you have SPSS only, you can open it.
Okay.
Am I correct, Monica, ma'am?
Yes. So Amos uses SPSS in the background. Okay. You need to have SPSS.
Yeah.
With your permission, ma'am, Monica, ma'am,
something
what maybe I would like to add upon. The trial version, if required, see, this is not, what do we say, formal, but informally, what I have learned in my practice is that if you're ready with your data set, then this trial version can be installed and you can start working on it. Because usually this has a limit of 1 month or 2 months, the trial version. So that was suggested to me by one of my professors. So I felt I could also share this knowledge with you all. Thank you, ma'am.
Thank you. So please let me know when you have the data set so we can go ahead.
Yes, ma'am, we could access it.
Okay, so this is how the data set looks like. I have empathy in here. As you can see, you have 5 indicators for empathy, 3 for attitude, 4 for attitude.
Monica, ma'am, are you sharing the data sheet? Yeah, now we can see. Yes.
Okay.
There's a quick, I'm sorry to disturb, there's a quick question, maybe very much related to the topic. Is there any condition on the number of statements a construct should have? Like empathy has 5 statements, attitude has 4, and response has 2. I think it is minimum 2. Am I right?
Yes, it has to be minimum 2. But there is no magic number to it. But so generally all the constructs should, it should be fair for all the constructs, if you want to say it that way. So you cannot have 2 for one and 10 for the other variable. That's not fair for both of the constructs. So we need to have somewhere, if it's 3, 4, 5, that's okay. If it's 7, 8, 9, that's okay. If it is 7, 10, and 5, that's also okay. So you need to, there's no number to it, but you just have to see that you're doing a fair job for all the variables, all the constructs in your model. That's all I would say. But yes, there have to be 2, at least 2 indicators. If it's a latent variable, it has to have at least 2, then otherwise it doesn't make any sense. Otherwise it's an observed variable. So yeah, minimum 2. But 2 will not make a very good case in favor of you. If you have just 2 indicators, that's not going to be a lot in your favor, because then they're going to question whether it really is a latent variable or not. But yeah.
Thank you, ma'am.
Okay, so you can see the data set here. We have 5.
It's visible, ma'am.
Okay, 5 indicators for empathy. We have 4 for attitude, and we have 3 for response, and that's what we're going to do. This is the variable view. If you go to data view, you see all of those numbers coded already in here, and we're not going to get into that. But what we're going to do is now we are going to open our Amos, and you see if you can open your Amos in there. Please let me know when you are there.
I don't have AMS.
Oh.
So Chitra ma'am, I think if you can put the link. Yesterday I have sent one link in mail, the trial version link. If you can download that, I think it can help you.
Yes, ma'am. Now, because of the catch, what I heard, I think that Monica ma'am, it is better that they will download afterwards and use it when the data set is ready. Is that okay? No?
That's okay. Yeah. Just let me know if somebody has it or not right now, so that I can continue accordingly.
Yes, because Dr. Amina madam has already told she has downloaded, so they have it.
Okay, so I'm just going to quickly go through this because to some it may not, they might not be as involved as others. So we're just going to quickly go through this. This is what you're going to see once you open Amos, a new file. This is what comes in the beginning. What you're supposed to do here is, this is a portrait style here. What we do generally to ease our pain is we go to view and click on interface properties, and then we go to landscape A4 paper size. We select that, apply, and we get a big screen to work on. So that's just a hack, an Amos hack that you all should know to just ease the work that you're going to do in here. So once you have this is just basic. What we do is we have all of these are all the shortcuts on the left. And this, when you work with Amos a lot, you'll just remember them, which shortcut means what. We don't have to go through all of those, but these are all shortcuts which you also can find up on top of this. If you don't know what they mean, you can just go in here. For example, if I go on diagram, and then you see the same shortcuts in here: draw observed, draw unobserved, and so on. So I'm just going to take, because this is very simple, we see here draw on unobserved variables. Remember, we have latent variables. We have empathy, attitude, and response. So we're going to draw all 3 in here. This is our empathy, this is our attitude, and this is response. Next, what we want to draw is, we want to draw 5 arrows here, and then 5 rectangles, and then again 5 ovals for errors, and then again 5 arrows down here. So to simplify, we have a shortcut here, which is draw a latent variable or add an indicator to a latent variable. We click on that, and then just click on the first one, which is empathy, 5 times, because we have 5 indicators. So 1, 2, 3, 4, 5. So you have these 5 indicators with 5 error terms for empathy. Similarly, for attitude, we have 4. We're going to do 1, 2, 3, 4. For response, we have 3. So 1, 2, 3. Once you're done with that, you can click back again on that shortcut and then go away. So because this is, again, one more hack, because this is going beyond the boundaries, we're going to click here on resize the path diagram to fit on a page. You see there, those arrows with paper and those arrows, you click on that and it's just going to resize everything here so that it fits in the page. Once you're done with that, we are supposed to name these. And I'm going to quickly do something here. You can ignore me for a minute. Okay. Okay. Yeah. Okay. So what we're going to do next is we're going to name all of these. So we're going to double click here on this oval and we're going to write empathy. Once you are in there, you can just click anywhere, click on the second oval, and this is still open. So you can write attitude here. You can click on the third oval and write response here as the variable name. Now, Amos is very sensitive to all the information that you put in there. It gives you an error very easily. So you have to make sure that you do not make any mistakes. It does not accept if the variables or anything is not named. So you need to name everything. So because these are errors, you also need to name these. In order to simplify and not name these as error 1, error 2, error 3, and so on, what we do is we can go to plugins here on top, and we can say name unobserved variables, and it will name everything randomly. It assumes that these are errors, and that's why it just gives these names, the small e1 up to whatever number of errors you have. If you do not name these latent variables, it's also going to name them randomly. So if you might see E1 into E12 and then E13, E14, E15 if you do not name them first. So make sure to name all of your variables. Now we also want to name our indicators. But what we'll do here is we will not name them. What we'll do here is we'll bring our file, the SPSS file, and we'll import the data and see what happens. So we go to file and then we click on data files here because we want our data file. And then we click on file name. And this practice data is what we double click. And then we press OK. So our data file is somewhere in Amos now. Amos has taken that data file and has absorbed in itself. What we're going to do next is we're going to view the variables in data set. That is, we're going to view that data file in Amos. We're going to take that. This is where that data file is. And we are going to just pull up these. So we have empathy 1 to 5. And we're going to pull these. So double click here and pull it to the first indicator. Double click here and pull it to the second and go so on. So we're going to quickly do this. Then we go to attitude 1, attitude 2, 3, 4. Again, same for response 1, 2, and 3. Now that it has taken the names from the SPSS file, we don't need to name them. So this is what we get when we make this, really put those constructs in there. This is our measurement model. We haven't, this is not what we're going to test. So we put it in here. And at this point, what we're going to do is we're going to create two files. So we're going to save this first. Okay. And let's say 1. I'm going to name it 1. You can name it whatever you want to name it. And then we're also going to save as and say 2 and then save again. So right now I'm working on file 2 and I've kept 1 to work later on. So what I'm going to do here is I'm going to check for my model fit. I'm going to check if this model fits together or not. In order to do that, I need to draw covariances among all these three. In order to draw covariances, I'm going to click on this double arrow and I'm going to draw these: empathy to attitude, empathy to response, attitude to response. So all the covariances, once these are drawn here, I'm going to save it again. You can go to file and then save. And then I am going to analyze. We're going to conduct the analysis. So we're going to analyze, calculate estimates. Click on that and it's gone. I don't know why. Let's see. So once you calculate estimates, you can view the text output. Okay, wait a minute. Okay, and then you can view text output. So this is like we get in SPSS an output file. This is similar to that. It has some notes for model. Here it shows us the chi-square value. It shows us the degree of freedom, and it gives us a p-value. Now, in order for the model to fit and see if the model has fit or not, we go here on the left hand side, you see model fit. We click on that and we get all of this information. Now, in order to see, and I had shared some readings with you all before, there you can check what the numbers should be in order for the model to fit. But on top, whatever is on top of my head, I'm just going to talk about that. So this is the chi-square value, this is the degree of freedom, and this is the p-value. And at any point of time, if it shows that blue highlight, you can click on it and it gives you some detail about that number. It tells you what that number is about. So this p-value tells us that there is a significant difference between population covariance matrix and the sample covariance matrix, which is not what we want. We do not want there to be a difference between the population, the total population that we are interested in, and the sample that we have taken. So we don't want that to be different. So this is giving us statistical significance, which is not good for our model. But in my experience, all the research that I have done until now, that has involved SEM. I have never received an analysis, a model fit with an insignificant chi-square. So this is not very important. You have to look at it, but it's not very important. You can ignore it. Go ahead and look at, let's say, GFI. We look at GFI, which should be greater than 0.90, and it is, which means our model fits. We also look at CFI, which again should be greater than 0.90 or 0.95, some say it is. We look at TLI, it's more than 0.95. We look at IFI, it's more than 0.95, and all these are more than 0.9 at least. So we can say that our model fits. We also look at here RMSEA somewhere here, the RMSEA. It should be less than 0.06 and it's more than 0.07, but it's okay because others are, it satisfies the other requirements. So you basically, there's no thumb rule for this, but you have to look at a combination of numbers and see if you're getting what you're supposed to get. And those numbers, if you achieve some of those, you can say that you have achieved a satisfactory model fit and you can go ahead with your analysis. But if everything is going beyond limits, then you do not have a model fit and you have done something wrong. Your model doesn't fit together and you have to stop over there and start reworking on the process that you have completed until now. Is that, do you have any questions? Does it make sense? Any questions you want to ask at this point?
Ma'am, there's no question, but what I felt is, can you just once go through this model fit? Like, what are the important things? Like, once again, can you just highlight those?
Yeah,
GFI.
Sure. Okay, I am just going to go to my slide here and come back to this. But yeah, this is what is a good model. The question is, what is a good model? And you look at these fit measures, the chi-square test, which should not be significant. You have goodness of fit index, GFI, which should be greater than 0.90. And all of these, TLI, CFI, all of these, Tucker-Lewis index, comparative fit index, all of these generally should be greater than 0.90 or 0.95. RMSE, that is root mean square error, should be less than 0.06. And you have many more that you get there in the output file. But as I said before, you do not have to look at all of them. These are the common ones that are used in research, that is GFI, TLI, CFI, and RMSE that are used in the research, and you have to report them. And if all of these or majority of these have the satisfactory, are within the ranges that are required, you're good to go. Your model does fit. Does that?
Ma'am,
Yeah.
suppose 1 or 2 doesn't fit, then what? It doesn't come up in the required range.
If 1 or 2 do not fit, for example, let's say GFI doesn't fit, TLI doesn't, the chances are that CFI is also not going to fit, RMSE is also not going to fit. So if you see generally chi-square, you will get, you can ignore chi-square, that's okay. Root mean square error, RMSE, it should be less than 0.06, but it does not have to be above 0.1. That if it's 0.1, you're going to get GFI, TLI, CFI, everything is going to be, here and there. You're not going to get them in the ranges. So it's not that it doesn't know. So it's kind of like they all know what they're doing. So they all are either going to match or completely not be out of bounds. So out of the limits. So if there is 1 or 2, for example, RMSE is 0.07 and not 0.06, it's still okay. And there is no, nobody there who's going to say, no, your RMSE is not 0.06 and it's 0.07, then your model does not fit. If you have the supporting argument of GFI, TLI, and CFI, which generally you're going to have a similar result in that, it's okay. It's good. It's okay to say that, yes, it did not go to 0.06, but I have this which says that it fits, and nobody is going to question that. So so yeah, 1 or 2 is okay, but the rest have to be there. And even if you do not use these and you try to use, let's say, IFI or BIC or BCC, you may have a question from the reviewer, and then they may say, why didn't you use GFI, TLI? Because those are the famous ones. So they will have a doubt in their mind, and it's up to you how you want to answer that. But generally you get the same results from all of those.
So ma'am, that means that we can ignore the lower ones, IFI, NFI, and so on. We do not need to report them in our data, like while reporting the data.
No,
right?
we just do not report. No.
Okay, thank you, ma'am.
Yeah, we only report the chi-square test. We do report the chi-square test, whether it's significant or insignificant. We do report it. And then we do report generally RMSE, even GFI, and then TLI, CFI are also, some people report it, some people do not. But yeah, you don't have to report the others at all.
Thank you, ma'am.
There is a question, ma'am.
Yeah.
Professor Joseph has asked, what is the minimum number of fit measures that need to be within range for a good model?
Very difficult question, very good question, but a very difficult one. As I said, there is no minimum range. It's up to the reviewer whether they are satisfied with your reporting or not. They may ask for more. They may just ignore it. Generally, if you have a good goodness of fit index or RMSE is within ranges, the chances are that they're not going to ask for others, because the assumption is that if these came out well in the ranges, the others were also in the ranges as well. So there is no specific number. It's just up to the reviewer, whoever you're going to send your paper to. If the reviewer is in a good mood, they're going to accept it as it is. If they are not, then probably you're going to hear more questions from them. But in general, you report these: chi-square, GFI, TLI, CFI, and RMSE.
I have a very general doubt because what I felt is during the confirmatory factor analysis itself, we will know whether it is the model fit is happening, means is it right or wrong. So because we are doing confirmatory factor analysis, the goodness of fit index will also be, above 0.95. So there itself we'll actually get the answer. Am I right in my understanding?
Not necessary. Not necessary. So even though we are doing this confirmatory, so why are we doing confirmatory factor analysis? If somebody has already made these indicators, so the questions that I used, for example, for empathy, I used those 5 questions. I did not make them up. I used them from somebody else's research who has demonstrated that these work. But what happens is, but still I'm using confirmatory factor analysis. Why do I need to confirm if somebody has already demonstrated that this works? Is because they did not use or I am not using the exact same respondents as that guy used in their paper. So what the situation has changed, the respondents have changed, the moods around have changed, the environment has changed. So we want to confirm that it still holds good. We want to confirm that somebody made these scales 20 years back, 50 years back, 100 years back. They are still in the working condition and they still work. Even if somebody made it yesterday, we still want to confirm that it works with the respondents that are our respondents. It works with our sample. So yes, you're right in thinking that we are using the confirmatory factor analysis to confirm, but we are conducting that analysis because we are not sure. We don't know. And it has happened that the model doesn't fit and people are, bothered. They get bothered because of that. And there are ways where you can make the model fit, which we are not going to get into. But yes, you can do some manipulations to do that. But yeah, it doesn't have to always fit.
I would request the participants, if they have any questions, to please post them in the chat box, and we'll wait for 2 minutes, ma'am.
Okay.
Yeah, excuse me, ma'am. Can I ask the question? Am I audible?
Yes.
In case if these variables doesn't come to the value which is like told by you, like 0.9 and above and 0.06 less than 0.06, what could be the possible reasons of these values, not reaching to the expected number? What could be the possible reasons?
Because the model doesn't fit. What does it mean by model not fitting? Is that sometimes what happens is that, for example, I measured empathy. Okay, in my original model, I measured empathy and I also measured emotions. So sometimes what happens is that I am thinking that I am measuring empathy by asking them certain questions. But actually what is happening is that these questions are measuring emotions rather than empathy. That's just one thing that can happen. So your assumed indicators are not measuring the variable that you think they are measuring, but they are measuring another similar variable, and that happens very often in marketing. We have so many similar, and I can talk about marketing because I'm a marketing faculty, but we have so many constructs which are similar to each other. For example, we have attitude, and then we have attitude towards the ad, and then we have attitude towards the brand that was in the ad. So even though these are two different constructs, but the respondents might not see them as two different constructs. They think that attitude towards ad is actually attitude towards brand and vice versa. And when we put it in the software, it says that no, you're not measuring this construct, you're measuring the other one. So there's a high correlation between these two indicators, which is not fitting well in what you're saying. It doesn't fit, the model doesn't fit, there's something wrong in there. That can be one reason of model not fitting together, but there can be many more like that. That is one mistake, and as I said, it's very sensitive. The Amos and structural equation modeling is very sensitive. So one mistake and it's not going to give you the result, or it's not going to analyze for you.
Okay, thank you, ma'am. Thank you.
Monica, ma'am, there's a question.
Yeah.
Professor Seema, ma'am, has asked, if the model does not fit, does it mean that the instrument is not proper or the respondents have not provided proper answers?
It can be both. It can be one of the two. We don't know. So because you won't know, how would you know that your instrument wasn't correct and it was the respondents? How would you know that? If you have a way of knowing that, so what we do is, whenever we receive the data, the first thing that we do is we go through the data by just looking at it. We just go through the data and we try to see if there are some people, and we try to see, and we have certain procedure that we follow. If we are collecting data online, when we collect it online, when we get it back, you get to see the amount of time that every individual has spent on the questionnaire. So if it is a 10-minute questionnaire and somebody has spent 2 minutes on it, we just delete that data. Or if somebody has spent 20 minutes on it, we delete that as well. So the first thing that you do is you try to go through the data and see if there are any discrepancies that you see, if there's some abnormalities that you see, and you try to delete those either variables or data, depending on wherever the problem is. So once you do that, once you look at those steps, and we also, one more thing that we do here in the questionnaires is we put some attention questions, as we call them. So for example, if there's a Likert scale type question, which is strongly disagree to strongly agree, and we have a question like in case of my empathy scale, it was a Likert scale question. So it says, while watching the ad, I felt like I was one of the characters. That was one of the statements. And then we have to say strongly agree to strongly disagree. So what we do is we put those 5 questions there, the empathy 5 questions, and then we put a 6th question as say, please select strongly disagree for this question. And then there are many people who are just making those drawings and they don't even read the statements and they won't say strongly disagree, and we remove that person as well. So there are many ways you can work in the process of collecting data in order to make sure that the data is correct. The problem is not with the respondents. So if you have crossed that stage, then you can be sure, or at least you can maybe collect data again and be completely sure that the scales that you're using are not correct. So there are ways to find that out, but if it's just, there's no other way that you can say you can put the blame on one or the other, but you can just take precautions and try to see that the data that you get is perfect.
Ma'am, there's another question. Ma'am, please once again give me the commands for model fit. So Dr. Amina Babu has given this.
Okay, so I'm going to close this output file. I'm going to go here. So are you here? This is where you are. Can you confirm that for me?
Yes, ma'am. Yes, I'm there.
Yes, ma'am.
Okay, you save this file. You have to save two different files. So you save this file somehow. Well, you have to save the file before you can conduct analysis. So once you save that file, you go to Analyze on top, and then you click on Calculate Estimates. Click on that, the first one that you see there.
All right.
Once you click on that, it doesn't do anything. It just does some work in the background. And then you go to View and Text Output. Here. Once you're in Text Output, on the left hand side, these are the notes that you get, like for example, for the same way like you get an SPSS output file. You click on Model Fit, and this is where you have those.
Thank you so much.
There's one more question, ma'am. While knowing new age tools or techniques, give an edge to your paper, but what kind of research should use SEM? As in at the outset, you look at the topic, area, and decide for SEM. Basically, why should SEM be used by a researcher? Professor Surabhi has asked this question.
Okay, I did not understand the first part.
Surabhi ma'am, would you
Yeah,
please?
yeah, ma'am.
Yes, ma'am.
It's a very generic kind of a question which goes to the background. Like we have so many new tools coming up, but nowhere it's decided upon that why anybody should go for these tools just because they are fancy, they are new. That's why we should be using them, or it should be totally dependent on the topic or the kind of research. So I mean, it's like there's such a horde race behind these tools. I'm being very honest and transparent here. But why? What kind of research that we look at the topic and we should decide for SEM, or we should be more considered, considerate about the fact that we have to read more and then go for these. So it's very hazy if you think of these aspects. So I hope I'm clear.
Yeah. Okay, very good question. So when you decide on, it's not that you have to catch somebody in the race and you have to win the race, and that's why you want to use SEM. It is a fancy tool, yes, I will agree to that. But why do we want to use SEM? Why do you use ANOVA, or why do you use regression? You decide to use those tools because of your model, because of your research that you have. It's the same way it's for SEM. So you use ANOVA because you want to compare two different groups, right? You want to compare, for example, males versus females leading to whatever. Why do you use regression is because you have, those relationships, you want to test them, and you generally do not have two groups in regression. And again, why do you use linear regression? Because you have one IV and one DV. Why do you use multiple regression? Because you have more than one IV and one DV. So similarly, for SEM, you use SEM because of a reason. And the reason is that sometimes what we do is we don't have such simple models like IV leading to DV, or two IVs leading to one DV, or comparing two different groups and seeing what the output is. We do not have such simple models always. We have IV leading to DV, that leading to another DV, then having some moderation, having some mediation, and so on. It can be as complicated as you want to make it. But there are these complicated models. Now, when we make these models, we kind of promise to the reader that the model that we have created, the complicated model that we have created, it works all together in one go. That is, for example, we say that if you read to your child daily, for example, I'm just going to give you some day-to-day daily life example. If you read to your child daily, if the child sleeps on a certain time, if the child eats healthy, and so on, you have all those things that is going to make the child, I don't know, I'm just going to say some random stuff. It's going to make the child intelligent. Okay, so we cannot say that, wait a minute, I am just going to feed my child healthy and test whether that leads to intelligence individually. Now I'm going to make another child sleep, or the same child sleep on on certain time, and then see if intelligence. What we want to test is that all these three are working together to make the child healthy. That's what SEM does. SEM does not break down the model, but it tries to test it all together, putting it all together. So SEM is used when a model does not make sense when you're breaking it into parts. If you break the model into parts, you're saying that the IV1 leads to DV, but ignore our IV2 leading to DV. You're saying that these two relationships are working individually, separate from each other. That's what we test. When we test for regression, using regression, that's what we test. We test our individual relationships and not the complete model. However, SEM tests the whole model together.
So can we say that for when the relationships are too complex, then to have better interpretations, it's good to use SEM? Is it how, I mean, we can think about?
In general, I would say yes. But again, would depend on the specific model. Would depend on if you're really trying to test the individual relationships. So in general, I'll tell you, when we have three streams of, if we want to divide research into three parts, we have strategy. We divide it into three parts. Strategy. We have research that handles strategy. We have research that handles consumer behavior, and we have research that handles the quantitative analysis. So let's forget about the quantitative analysis. But in broad terms, we have for marketing, we have strategy and consumer behavior. So generally in strategy, if you're looking at strategy, you're looking at strategizing something in an organization, you would want to use SEM, because you would want to see how everything fits together, how everything leads to something else, while the other variables are also present. However, in consumer behavior, you can divide them. You can break them down into different pieces and then study each of them individually. Generally speaking, it may be, it obviously is dependent on what exactly your research model is. But generally speaking, yes, if you want to strategize something, put it all together and use SEM. If it's about something psychology or something related to consumers or people, you can go ahead and break it down into different pieces.
Monica ma'am, we do have excellent feedback, and we are going to share with you the feedback. So one thing before we could wind up, or if the questions are over, our Director General is here. So,
okay,
sir.
Do you want me to stop sharing?
If it is done, yes, ma'am.
I would just take one more minute here because I did not finish. So I'm just going to tell you
please,
just one more minute. So this is up to now what we did is we just saw whether the model fits or not. Next, what you do, if the model fits, next what you do is you actually check the hypothesized model. So you make that, remember we saved two different files. So one of the other file that you saved, you bring that up, bring that in again, remove the covariances and put these arrows, just put these arrows in there, and then go ahead and do the same. Save it, estimate, calculate estimates, and then check the output file and you will see the results. For example, and then I'm not going to cover this, but just quickly, I want to show you how those results look like. The model here, I had done it already. So this is how the model, the next model that you're going to make, you have to give the error terms to the endogenous variables. Remember, you analyze, calculate estimates, Oh, okay, it needs. Anyway, you get the output file, and once you get the output file, you'll see whether your hypothesized relationships have worked or not. And if you want want to know more about it, feel free to get in touch. Thank you. I'm done. Sorry for taking an extra minute.
Thank you, ma'am. Sir, Director, sir.
Yeah, I'm there. So, good evening, Dr. Monica.
Good evening.
Good evening. Of course, good morning for India. It's a pleasure having you here. I was watching your program. It was really amazing and very useful to all our participants. I'm looking forward to many such interactions with you. Hope you will oblige. And a lot has been told about you by your friend Dr. Suchitra, and also we heard about you. So thank you so much. I'm looking forward to.
Thank you so much. The pleasure is all mine.
Okay, thank you.
Thank you, sir. Before we wind up the session, the feedback form is posted in the chat box, as well as it is posted in the WhatsApp group. And the link will be open for the next 1 hour from now. So please provide your feedback. Ma'am, thank you very much, Dr. Monica Rawal. That was an enriching session on SEM with Amos. The session was so interesting that we were thinking that it should not end, but it has ended. The session gave us insights into confirmatory factor analysis, regression, a small part of it, how it will be useful, and how do we really construct a model building. So I'm sure not only our own faculty members, but all the participants would take this opportunity to practice the session, and this would be useful for their future research. I would like to thank our Director General, Dr. Prasad Rao sir, for giving me this opportunity to be a part of this wonderful FDP and to learn this new topic, structural equation modeling. I also owe my thanks to AGBS Noida for encouraging us to conduct this FDP, and all the participants for their very lively and active participation, and without whom this entire session would have been incomplete. Once again, on behalf of AGBS Hyderabad, I would like to extend my sincere thanks to Dr. Monica. The main reason is because in spite of the time difference in both the countries, she readily accepted when we requested her for this session. So thank you, ma'am. We come to an end of the first part of the day 2 FDP, and the second session will be starting in next 15 minutes by Dr. Sashi sir, and the same link can be used to join the session. So we'll take a 15 minutes break, ma'am. Thank you, Monica, ma'am.
Thank you. Thank you so much. Yeah. Bye.
Bye, ma'am. Thank you, sir. Thank you, everyone.
Thank you.